In question 10, the function f is such that f of x is equals to 2x plus 3 for x greater than equals to 0. The function g is ax squared plus b, where a, b, and q are constants. The function fg is 6x squared minus 21 for x less than equals to q. In part 1, we have to find the values of a and b. Now, as the function fg is given, if we have to find the function fg of x, it means that in the function x, we'll replace it with the function g. So as it is 2x, the x will be replaced with the function g, which is ax squared plus b, and this is a plus 3 up here. Now, as this is equals to 6x squared minus 21, so we can expand it and write it as 2ax squared plus 2b plus 3, and that is equals to 6x squared minus 21. Now, comparing the coefficients, on the left-hand side, the coefficient of x squared is 2a. On the right-hand side, it is 6. So 2a will be equals to 6 and a will be equals to 3. The constant term on the left-hand side, that is 2b plus 3. So we can write 2b plus 3 and that will be equals to minus 21. So taking 3 on the right-hand side, this will be 2b equals to minus 24 and b will be equals to minus 12. So the values of a and b are a equals to 3 and b equals to minus 12. In part 2, we have to find the greatest possible value of q. Now, q is basically the value that the function g is taking over here. And for fg of x, it is also the domain of fg function, x less than equals to q. Now, we know that for the function f, x has to be greater than equals to 0. And when we form the function fg of x, it basically means that this x is now replaced with the function g of x, which means that as this x has to be greater than equals to 0 as given in the question, it means that this g of x function must also be greater than or equals to 0. So in part 2, as we know that the g of gx function is now the value of a is 3 and b is minus 12. So we can write that g of x is equals to, in place of a, we can write 3 and this will be 3x squared minus 12. So to find the value of x, which is basically the value of q, we can write it as 3x squared minus 12 has to be greater than or equals to 0. Solving this, we'll get 3x squared is greater than equals to, taking 12 on the right hand side, we'll get 12. So x squared will be greater than equals to 4. Taking the square root, we'll get x is greater than equals to plus minus 2. Now, as the question said that x has to be less than or equals to q, so we have plus minus 2, both of these values over here. Now, if we make this function over here on a quadratic graph and the values of x are 2 and minus 2, so this is 2 and this is minus 2 up here. So as this value has to be less than a particular value, so we'll take that as x has less, x will be, or the value of q basically will be, so q will be less than or equals to minus 2, or we can write that q will be equals to minus 2. Now, for this to be greater than 0, it would have been greater than 2. So we would have taken the values x greater than equals to 2 and x less than equals to minus 2. So as in the question it states that x has to be less than equals to q. So we'll have to take this value, which is minus 2. So q will be equals to minus 2. It is now given that q is equals to minus 3. We have to find the range of fg. So in part 3, we know that the fg function, fg of x is equals to 6x squared minus 21. And x is less than equals to the value of q is given as minus 3. So we can substitute x equals to minus 3 into this equation. So fg of minus 3, substituting minus 3 over here, we'll get minus 3 squared is 9. So 6 times 9 is 54. 54 minus 21 is 33. Now this value, as x is less than minus 3, so even if we take minus 4, minus 5, minus 6, all of these will become positive and this will keep on increasing, which means that the range for the fg function, we can write that fg of x. So fg of x will be greater than or equals to 33. In part 4, we have to find an expression for fg and state the domain of fg inverse. Now the fg function is 6x squared, so fg is equals to 6x squared minus 21. To find the inverse, we can first write it as y is equals to 6x squared minus 21. So this is not a 1 up here, this has to be a 21. So 6x squared minus 21, exchanging the values of x and y, this will become x is equals to 6y squared minus 21. Taking 21 on the left hand side, that will become x plus 21 is equals to 6y squared. Now dividing by 6, we'll get y squared is equals to x plus 21 upon 6. Taking the square root, this will become y will be equals to the square root of x plus 21 upon 6. So we can write that the fg inverse function will be equals to the square root of x plus 21 upon 6. Now it is also asking us in the question to state the domain of fg inverse. Now the domain of fg inverse will be basically be the range of the fg function. Now the fg function was greater than equals to, so this would have been a 33 up here, which means if the range is for the fg is greater than equals to 33, it means that the range for fg inverse function will be x is greater than or equals to 33.